So let's compare average rate of change, which is our previous topic, and instantaneous rate of change, our current topic. All right, we know that they're both dealing with how the function is changing, which is good because that's the study of calculus, how functions change. So we're on the right track here, but there's differences between the two, and there are some similarities in some cases. Okay, so average rate of change, we're finding the average rate that the function is changing over an interval. We have a starting value of x and an ending value of x, and they are different values. Okay, so a to b, all right, x equals 2 to 7. A would be 2, b would be 7. But we're finding the average change over some interval. With the instantaneous rate of change, we are looking at how the function is changing at one specific point. No interval, just one point, and that point is x equals a. Okay. The average rate of change, if we're talking about a graph, the average rate of change is the slope of the secant line. So let me just put in here a graph. Okay, so if we're dealing with a graph, and we were asked about the average rate of change, we're interested in the slope of that secant line. Okay, remember from geometry class, if you had a circle, okay, a secant would be a line which cut across 2 points on the circle. Okay, that was a secant line. Now take away the circle, just make it a curve. Okay, now if we have just ourselves some kind of curve, you can see how the secant line is cutting through that curve at 2 points. But if we're looking at the instantaneous rate of change, now remember those data points are very close together. In fact, they're one on top of the other, basically. So it's no longer the slope of the secant line, it's the slope of the tangent line. Okay, so think back to geometry again. You had a circle, okay, and the tangent line was the line which came and it just touched the edge of the circle at one point, not at 2 points like the secant line. So if we turn this circle into a function, like we did over here, okay, the tangent line is going to touch the curve only at one point in this area. It could cross the curve later on. Our curve could then go up this way, and our tangent line, yeah, it would cross right there, but we're not concerned way over there. We're only concerned in this one spot, and at that one spot, the tangent line just touches the curve only once, whereas in this region, the tangent line touched the curve twice. Okay, so it wasn't a tangent line, it was a secant line. So secant line is the graph when we're dealing with an average rate of change. Tangent line when we're on a graph and we're looking at the instantaneous rate of change. We're trying to find the slopes of the tangent line or the secant line. Okay? Now if we're dealing with an equation, all right, we're given a function and it's in an equation form, well now our formula for the average rate of change, as we've discussed, f of b minus f of a over b minus a. And you saw in the previous video how we took that formula and we turned it into the limit as h approaches 0 of f of a plus h minus f of a all over h. I know in your notes there's x's here and here. Just turn them into a's, please. Should have been at a. It's a typo on my part. So again, this is the instantaneous rate of change when you're given a function, well, I should say an equation, rather, an equation here. All right, you're going to use this for the equation. You don't use it on a graph. You don't use it in a table. You just use this when you're dealing with an equation. Okay? So finally, overall, what we're looking at, because we've talked about graph, we've talked about equation, when we have a table, okay, we can get the exact answer for the average rate of change. We just find the specific points that we want, f of b minus f of a over b minus a, and we're good to go. We cannot get an exact answer for an instantaneous rate of change from a table. All right, so if you've got a table, you can only get an approximation. How do we get the approximation? Well, we're going to use the average rate of change. So if you're given a table, you're doing the same thing on either side. You're doing an average rate of change no matter what. But if you're asked for the average rate of change, well, then you're going to get the exact answer. If you're asked for the instantaneous rate of change, you're going to get an approximation, okay, but you're going to use the average rate of change to get that approximation. Okay, so there's your comparison, and your contrasting between the two, the average rate of change and the instantaneous rate of change.